In today's video, we're going to tackle stars. What are stars? Stars are big balls of gas with nuclear fusion happening in the center of them. That's it. That's what stars are. Let's take a deeper look at it. Here are the stars of the universe. Right here, right in front of you. There are only, probably like 100 stars on this thing. In reality, there are a lot more than 100 stars though. So let's work our way through this chart, first through what's called the main sequence, and then we're going to work our way through white dwarfs and giant stars. So when you see from the bottom right of this picture, a bunch of small reddish stars, and on the top left, bigger bluish stars, so not looking at the humongous ones at the very top, but rather right below that, the one that's labeled Beta Centauri, for example. That's called the main sequence. On top of that, those humongous blue ones, and to the right, all of those humongous red ones and yellow ones and whitish ones are all giant stars. All the ones on that sequence that I indicated before are main sequence stars, and all the stars underneath the main sequence are called white dwarfs. So let's get into each one of those respectively. Let's start with the main sequence. In order to be a star, you have to be about 1/8 the size of the sun. If you're not 1/8 the size of the sun, you're probably not going to get any fusion started, and you're just going to be a big ball of gas floating around there. We call those brown dwarfs, in comparison to red dwarfs, which are the smallest type of stars. And those are those reddish small stars that you see in the bottom right. Now, what makes the main sequence is that all of these stars in their cores are burning hydrogen to helium. And that's what most stars spend most of their lives doing. And depending on how big you are, that's going to determine where you end up on this diagram. So if you're pretty small, you're going to end up in the lower right. If you're very big, you're going to end up in the upper left. But again, all of these burning hydrogen to helium. So you just look at the mass, and depending on the mass of the star when it gets going, that's going to determine where it is on the main sequence. However, as a star goes through its life, if you're a reddish star, you're probably not going to end up burning anything more than hydrogen into helium. You're probably not going to be able to burn helium into carbon. That takes more mass. That takes more gravitational energy. And therefore, once you run out of the strength to continue burning hydrogen into helium, or you run out of hydrogen such that you have to burn helium now, but you can't, you're going to become a white dwarf. You're just going to stop fusing, and in a sense, stop being a star at that point. You're still going to be pretty hot, but you're going to be a lot less luminous, and you're just going to fade across time because you're not doing nuclear fusion, you're a white dwarf, and that's how those stars end up underneath in the white dwarf camp. If you're a bigger star, and you're able to burn helium into carbon and helium into oxygen, and so on, then you're not going to become a white dwarf, or at least not right away. Instead, first, what's going to happen is you're going to blow up. The moment you start burning helium, you're going to blow up into a humongous star. And depending on how big you are initially, you might blow up into a red giant, or into a red supergiant, or into a blue giant, or a blue supergiant. Now, for a lot of these stars, any one of these stars that's really 10 times or more the size of the sun, those stars are going to be likely blowing up to die. They're going to turn into supernova, and they're going to leave some remnant, and they're going to disperse a lot of heavier elements into the surrounding atmosphere. But if you're not big enough to blow up into a supernova, so some smaller red giants are going to end up as white dwarfs as well. And that's really the story of all these stars. So the story of all stars are, 1, mass is most of the story. The bigger you are, the brighter you are. Your initial size will determine your life, will determine what color you're going to burn, how long you're going to burn for, whether or not you're going to be able to burn past hydrogen into helium to higher levels or not, and correspondingly whether or not you're going to end your life as a white dwarf or as a supernova. Next time, we're going to take a look at planets, because a lot of these stars have planets around them, and they're the next biggest thing. So until then, cheers.